For number 5, a cannonball is fired from a cannon located at the edge of the cliff with a head H at an angle theta above the horizontal. A resistance is negligible. You're given this graph. Again, we're asked what's wrong with this and to justify our answer. This is not a constant slope. This is an accelerating object. Okay. In the horizontal, there is no acceleration for projectile motion. We are not talking about acceleration in the horizontal direction. So this object that is being shown in this graph would not represent this cannonball since it is not accelerating in the horizontal direction. Simply put, that's that. The cannonball is not accelerating in the horizontal direction. It should have a constant slope. Okay. Cannonball is then shot horizontally from the cliff, which is 34 meters tall. Cannonball has an initial velocity of 540 meters per second. Calculate the distance the ball travels from the cliff. This is something you're not being asked to do necessarily is calculate values, but this is a range problem. And you've seen this earlier in which you could figure out the range. In this case, it's shot horizontally, so we don't have to worry about angles. Subject is shot like this at a velocity of 540 meters per second. Okay, and it's going to drop a distance of 34 meters. Okay, so blah, 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 blah. It's going to drop eventually, right? We want to know what the x value is here. Funny enough, right? We did a calculation for this earlier. So you could work it out again if you wanted to. But I'm just going to go back to question number 1. Look at that boy jumping off the cliff and look at my range equation there. So this is my range equation here. V0 square root of 2h over g. So I'm going to use that equation for this, and I'm not going to bother to derive it again. So that distance from here to here is going to be x is equal to v0 2h over g. H is our 34 meters, v is our 540 meters per second, g we can just say is 10, and so we can calculate our value as 540 meters per second times the square root of 2 times 34 meters over 10 meters per second squared. Okay, so then we can calculate whatever that value is. I frankly don't even bother doing this, but let's see what it is. So 68 divided by 10, and then square rooted times 540. So it's going to travel about 1,400 meters. All right, you can round, it's rounded up to 1,400 meters, but like 1,408 or something. Okay. Again, I just wanted to point out the fact that you had the range equation already, and you can plug in any value into that range equation if the situation is the same as it was in the first problem, which is a horizontal velocity initially off some height, hitting some ground below. So C, the student now finds the equation R V0 square root 2hg for the horizontal range of the cannonball, where h is the height of the cliff and v is the initial velocity. Without deriving what's wrong with this, basically looking at this, what makes it not plausible, and then kind of explain our reasoning here. We already know it's not the right equation, but if we didn't know what the right equation was, what we could look at here is 2 things, right? First of all, units are really helpful here, right? If you look at the calculation we just did in terms of units, inside the radical here, you have meters over meters per second squared, right? So meters divided per meters per second squared, that just means that the meters cancel out, and so you get second squared. Okay. that's inside the radical, so we would square root this second squared and then multiply it by a velocity, which is meters per second, right? And that means that inside the radical, we cancel out the square, so we have s times meters per second, cancels out the second. So our final units would be in meters, right? That's what we want. That's the displacement. That's a distance, right? In the equation that you're showing here, doesn't make any sense. Since you have g up, next to the distance there, what you'd end up here is that you'd have inside the radical, you'd have meters times meters per second squared. Outside you have meters per second, and then we want meters to be the end goal here, right? So if I work this out, meters times meters per second squared would be meters squared over second squared, square root that, and that would be meters squared, or meters per second, times meters per second. And that makes no sense, right? Absolutely no sense. It would just end up being that meters squared per second squared. This is not at all rational, okay? That's one way to look at it if you're really comfortable with units, which I hope at some point you guys are. But if not that, think about how the situation changes as you change each of these variables, right? If I increase the velocity, the range increases. That makes sense, right? The faster I shoot off the cliff, the further it should go. Great. The more I increase the height, the more the range increases. Also makes sense. If I'm higher on the cliff, it gives it more time to fall, so it gives it more time to travel forward. That makes sense. What about G though? Right? I know we can't change G because it's a it's a factor of just like where the Earth is or what the Earth is like. But if you could change G to some other acceleration, would it make sense? If you were standing on the moon, right, and you were doing the same experiment where the moon the G value is smaller, right? So G gets smaller with the range, then also gets smaller. No, if you fire something on the moon, it would take a lot longer to fall to the Earth, right? And so it would travel a lot further. Same thing if we were to increase G, go to Jupiter, G becomes much larger, right? If the gravity is a lot stronger now, if the acceleration of gravity is a lot bigger, should the range be bigger also? So things are being pulled towards Earth faster, but the thing is traveling further? That doesn't make any sense either, right? So you can address this either way. You can talk about how as G would increase, the range should decrease, right? Because you know that gravity is what's causing it to fall to the ground, and the time it's in the air is what lets us get further in the range, right? So you can address this either way. Okay. Right. That's that one.